Hey Daniel, have you ever wondered how supernova occur?
You know, guys, I never really thought about it.
It's elementary, really. There's two ways in which a supernova might form. It's a high mass star that runs out of material and then it blows. Or it can be more complicated when one star in a binary system, it becomes a white dwarf and it starts to accrete material from the other star.
Wow.
Wow.
I never knew that.
Yeah, right?
I'm so smart.
A high-mass star lives its life on the main sequence like any other star. The low-mass star would not be able to fuse carbon and would become a white dwarf. The high-mass star's temperature is high enough to fuse carbon to oxygen, and so on until silicon fuses to iron. A star does not fuse iron because it does not get hot enough to overcome the opposition of same-charged particles in an element as heavy as iron. Also, fusion of iron does not yield any energy. In fact, it would actually use up some of the star's energy. Once the buildup of iron in the core reaches the Chandrasekhar limit, which is about 1.4 times the mass of the Sun, the outward pressure can no longer withstand the inward gravitational force. This causes the star to collapse in less than 1 second until the neutrons in the core repel each other enough to overcome gravity. The outer layers rebound off the now stable core, leaving behind the core in the form of a neutron star, a white dwarf, or a black hole. The explosive rejection of the outer layers is what we perceive as the supernova. Additionally, supernovae create elements heavier than iron, as there is so much energy that it fuses heavier elements higher and higher up the periodic table.
Hi. You know, if you were a star, you'd be a spectral type O.
Okay.
A Type 1 supernova occurs in a binary star system after one of the stars has completed its life cycle and has become a white dwarf. The white dwarf can accrete material such as hydrogen from its companion star and begin fusing again. This causes a sudden brightening of the white dwarf. When it starts fusing again, it is called a nova. Eventually, the white dwarf will gain enough mass from the companion to reach the Chandrasekhar limit, which again is 1.4 times the mass of the Sun. When this happens, the white dwarf collapses and heats up very fast. The increased temperature causes astronomical amounts of nuclear fusion suddenly, creating an enormous amount of energy. This release of energy ignites the entire star in a supernova explosion.
Hey there. How's it going?
Good, how are you?
You know, you're so hot that if you were a star, you'd be fusing carbon.
Hi there.
Hi.
You know, if you were in a binary star system, when you pass in front of the other star, there'd barely be a dip in brightness because you're so hot.
That's funny. Really funny.
Wow, I really think we learned a lot today.
Yeah, I didn't know there were two types of supernova. Science is terrific.
We sound like we're in one of those weird educational movies like Dr. Quantum.